So let's get started. Today I'm going to cover a couple of subjects. The first group of subjects I'm going to cover is from this textbook. So chapter 15, 16 to 21. So we have 1, 2, 3, 4, 5, 6 chapters. And I'm not going to cover every detail, just go through it really quickly. So the computer I'm using, all the zoom controls are floating, so it will disappear and reappear since I have no control. I was trying to, anyway, I'm assuming everybody can hear me, so all right, yeah, now it's yeah, my zoom control on Apple, this computer, it's floating everywhere. It appears and disappears with its own mind. I can't control it. Anyway, the 6 chapters is the first subject I'm going to cover. There I will cover the node red, which is I said it's my favorite. It's kind of a nice toy, very interesting. So let's go right into it. The first topic will be the boot. Boot is an interesting topic also. It's talk about how the Raspberry Pi load up. It turned out the Raspberry Pi loaded up operating system in 4 stages, or we call it a 3-stage bootloader. Generally, a computer is a 1-stage bootloader. When we talk about computer, we talk about we want to load up an operating system. When we're trying to load up an operating system, generally is a 2-stage, 1-stage, single stage. So that panel disappeared again. Okay, finally. Let me move to my. So you got computer, CPU. When you try to load operating system, the CPU first start with, when you turn the power on, the CPU will go to something on ROM. That will be your permanent program. So this program is generally not able to change. So this permanent program is provided for 2 reasons. First, the software manufacturer do not want to deal with the little details inside your computer. There are so many technical details about your computer. Every manufacturer make their own modifications. So all those details will be a huge headache if the software company have to deal with all those little details different. So this ROM was put over there to hide all the differences. So that means it will speak a common language to the software developer. So that's one reason your CPU load up your operating system through a BIOS. So this ROM just called a bootloader. So this bootloader is provided over there to isolate the differences of CPU. Another reason the bootloader is over there is because the operating systems are so many, and some on network, some are on the cloud, some are on the hard drive, some are on the SD card. There's so many different ways you can boot, load up your operating system, and the hardware manufacturer really do not want to deal with all those details. So instead, they just provide a bootloader. So bootloader is there. Generally, the first program it starts when the power turns on on the computer. We're interested in analyze the bootloading process. Let's talk about the Raspberry Pi. Raspberry Pi, the bootloader is a three-stage. This is called single stage, bootloader to operating. Raspberry Pi it started with a GPU. GPU ran a stage one. Stage one. The stage one will only the GPU will start access SD card. So by default, the Raspberry Pi runs on SD card because this is a ROM program. This program was not able to change. Actually, you can change it a little bit, but generally, it's printed, cannot be changed. So this stage one will just load up the SD card interface. So your SD card will start working, and then on the SD card there is another bootloader. So that is a stage two. Stage two is run a program is also GPU. It run a program on SD card. Run code on SD card. Stage one, the code is on ROM. It's part of the chip, part of the CPU. When you make the CPU, the code is already printed inside the CPU. So that's so stage two. Stage three will be when you run this code, it will load up a program to run to your computer memory. In the case of mine, I have 1 gigabyte. Some of you have 4 gigabytes. Some of you have 8 gigabytes, depend on the computer. So this stage two will load up, and it will load up the actual kernel of your operating system. So that's three stage. That's the last stage, stage three. And finally, the CPU will run the operating system on memory. So this is the bootloading, the boot process on Raspberry Pi. So stage one, stage two. Actually, stage one, stage two on GPU. It's kind of strange. The CPU was suspended at the beginning. Only the control is turned over to GPU after stage two. So stage one, stage two ran code on SD card. Then the control will turn over because the SD card, this program on SD card will load a bootloader on read and write memory. So why are we interested in the bootloading process on the Raspberry Pi? Because that's another project I kind of researched a little bit during the weekend. I put it on my project folder, so I will share it with you. So what I put it over here is a couple of projects related to bootloading. So it started here. The first is load up Raspberry Pi through Ethernet cable. So that means it is potentially you can run your Raspberry Pi without the SD card. So you might have 10 Raspberry Pi. You do not need a 10 SD card. All you need is a Ethernet connection to your SD card, to your Raspberry Pi. So that is that can be done right here by changing something right here. I also listed the different ways to do that for Pi 4 and Pi 3. It turned out Pi 4 and Pi 3 are different. Pi 3 used to be considered impossible, but it turned out Pi 3 has a little fuse inside. So you can blow that fuse on Pi 3, and then Pi 3, instead of go to SD card on stage 2, Pi 3 will turn on the Ethernet and USB interface in stage 2. So that means Pi 3 can be bootloaded without SD card, with only Ethernet or a USB drive, USB drive. So we can do a that's the next one. We can do a Pi 3 from USB drive. Why we want to do that? That is because the USB hard drive has much better performance and lasts much longer than an SD card. SD cards are not designed to be used as a hard drive to read and write repeatedly. So generally, SD card, it can write, for example, 10,000 times. So 10,000 times is the upper limit you can read and write from SD card. After 10,000 times of read and write cycle, your SD card is done. So SD card is not designed for that function. Instead, hard drive is designed for. So if your bootload or load your operating system, Raspberry operating system, or with a USB hard drive, you have supposedly have better performance in that way. So both Pi 4 and Pi 3 can be run without SD card using Ethernet or USB drive. That's because we can change the bootloading right here at stage 2, right here. So that's the advantage, obviously. Another advantage is on the hard drive, you have almost unlimited space. Also on Ethernet, you have unlimited cloud space. Server, the Ethernet, the other side of the Ethernet is a server, handle the. So on the Ethernet or on the USB drive, you have much bigger space. So I have a hard drive I purchased many years ago, 4 tera, yeah, it's many years ago. I'm assuming right now it's even bigger. I haven't checked the size of recent hard drives. Anyway, because you have this unlimited space, you can have unlimited, that's our next topic, unlimited amount of operating system. So you can have different bootloading images for all the possible operating system you want to experiment. What I have over here is a web page connect. There are so many different operating systems which can be run on Raspberry Pi, but if you classify them, there's 3 different types. Type number 1 will be Unix. Type number 2 will be Windows. Type number 3 will be RISC. So Unix is the one obviously most popular. Windows is the second. RISC operating system is a very rare operating system. It was developed by the same engineer who designed ARM processor. Remember ARM processor? ARM processor is the processor used inside Raspberry Pi, inside your cell phone, inside your smart TVs, inside your routers, inside almost everything. Even I'm teaching another class, electronics communication, even the radios. I saw, yeah, there's a popular digital radio controlled by ARM processor. So these engineers who designed ARM chip also designed an operating system called the RISC-R OS for their chip, but it's not very popular. If you're interested, you can download one of those and experiment. As far as the Unix, there's two Unix from different origins. One is called the BSD. That's the older one. That is the one I used when I was a student. Almost all the labs have a workstation, Unix-based. Also, the Macintosh operating system, Apple, use the BSD. So if you have a Macintosh, you are using a BSD operating system inside. Sony PS game consoles use Linux BSD. What else? There are so BSD is a very popular operating system. Linux is another one written by Linux. I guess his last name is Linux. So he was a graduate student, some country in Europe. When he was studying software as a student, he was studying this operating system BSD. So when he was studying the operating system, he started to write his own version of Unix from scratch. And it just so happens it became the most popular operating system. Right now, everybody using Linux. So BSD and Linux is the same operating system from different source, written independently by BSD, I suppose, written by some college professors. Linux is by college students. So that's two Unix. Linux is also everywhere. Most notably the Google cell phones. The core is a modified version of Linux. So there are so many different flavors of Linux around. So Raspberry Pi, the Raspbian is one of those. It's like a big tree, have 1,000 branches. So Linux is the tree. All the different flavors are like branches. They came from the same source code. The differences usually is the user GUI. The GUI is different. So I forgot I remember last week Jeremy showed us Twister. That's another branch sourced from Raspbian. So they didn't change Raspbian core. They only changed the user interface. So some people like that flavor. So on here, I have a link of 20 different operating systems you can experiment on your Raspberry Pi. If you have interest, just experiment. Just remember only 3 different types. Most are different flavors of Linux. So that's our first topic, chapter 16. We talk about the boot. The next chapter talk about the initialization. It's some interesting topics of run levels. So Raspberry Pi, this computer, because it's a Unix, and the Unix is designed originally only for multi-user. So your Raspberry Pi is a multi-user computer. It's not designed to be used by single user. It is designed the whole VNC. When I was a graduate student, we don't have a computer. Our department has one computer. Everybody use a VNC, version of VNC. Everybody have a username and password. And if you log in, you either log in from terminal, and when I'm doing my work, usually I just log in from my terminal and do all my work. But sometimes I need a Windows, so I just VNC. In that time, we do not call VNC, we call X terminal. So we use the X terminal to connect to our one big workstation in the department. And right now, when you run Raspberry Pi, you log in as a super user. So basically, you as a user control everything about the computer. In the case of multi-user, only the system administrators are super user. They control everything. You as a general user just control your own directory. So everybody has a home directory. So if you look at the Raspberry Pi, if I share my Raspberry Pi, everybody has a home directory. That home directory is for each user. So you have total control of your home directory. So that's your home directory. Let me log in to Raspberry Pi. So it is a multi-user platform. So that's your home directory. This is a directory you have 100% control. As far as the other directories, you have no control. The only person has control is a full-time computer guy. So he has a huge amount of knowledge about the system, and so he controls the system for the department. Department has many services runs on that Unix workstation, and so he controls the. So if you go up directory up a little bit, so this will be only one user right now. On the home directory, there's only one user, Pi. So you can have hundreds of users. So everybody need to do research, need to do work in the department or log in. And they all share the same one computer. That was in the old days. I'm not sure what it is today, but that was what was going on 30 years ago. Everybody share one computer, and everybody has a directory. And I remember once I was running my code. I guess my code, I was intentionally write a code which takes more computer resources. I was experimenting. So I ran that code, and then the super user, in that case is a lady, she come right to me, says, "What are you doing? You use up too much. You kind of did something bad to our computer." So that was because everybody share one computer. You want to make sure when you have this computer, the super user also runs servers. So you will run a web server. So our department web page at that time is controlled, is also on this computer. So you can run a web server, email server. All the emails is handled by that computer. Just like so you can have an email server yourself using Raspberry Pi. If you're interested in that, just Google. So let me Google a little bit how to run an email server on Raspberry Pi. So I realize I have to start the Windows first before I share. Otherwise, if I open up a new window after the share, you guys will not see it. I think that's for safety, because potentially you might share something you're not supposed to share, right? So let me. What? Did I turn off recording? All right. Let me share. Share my Google. Where is the Google? All right. So Raspberry Pi email server. Yeah, if you run an email server, just like the Clintons run their email server in their basement. So all the emails are private, kind of. So if you do not want Google, want Amazon, want Missouri Western, so if your email goes to Missouri Western, that guy, who is called Fred Nestle, can read all your emails, because he is the super user for that email server in our. Oh, our email right now is run through Google, so he kind of lazy. He didn't. So right now our school email is handled by. handled by Google. So suppose you do not want your email to be read by Google, you can do this. You can run an email server on Raspberry Pi. That can be an excellent project. So then what your email address will look like? Anybody interested in that? When you run email server, your email address will be unique. It depends on your IP address of your router. So you will have a one and only email address. It's not like at Hotmail or at Google or at Missouri Western. It will be at whatever you call your computer. You have to give your computer a name. How do you give your computer a name? Do your computer have a name? Yeah, you can give your computer a name. How can you give your computer a name? Let's Google it. Yeah, that's how you give your computer a name. So if you want to give your Raspberry Pi a unique name, like best dad, like number1dad.com, whatever. number1dad. You can have a unique name, give your own computer. This is called dynamic DNS. You can also pay for your computer name. I always saw this as GoDaddy. Yeah, that's a paid service. If you go to GoDaddy.com, you can grab a .com name for 1 year for $12. So you can have a. Well, this GoDaddy, I'm not sure how this works. GoDaddy. I would assume this GoDaddy.com is cloud-based. So that computer is also not in your basement. That's what I'm assuming. That computer is a cloud-based computer. So you have a .com name, and you can control whatever happens on that computer, but that computer is not in your basement. You do not have a physical code on that computer. So if you... Yes.
We used to use that for our website, and you can do things where you just buy the name and then point that name to anything you want.
Oh, wow.
So you could point it at a server. Yeah. I mean, or
okay.
I think so. Yeah. I mean, I wasn't that advanced then when we were doing this, but I just needed a simple website. But yeah, they have the hosting, or you can just buy the name there and just license it through them, and then that's all you do. And it just traffic just travels through there. But
yes, that's nice information. They redirect that .com name to your basement. Okay, so now you have physical control. Control freak, huh? You want to physically control that piece of equipment, but you never have 100% control because today's computer is so complicated. When I'm watching my router, I always wonder what's going on. So if you're interested in what's going on your router, what can you do? That's another thing you can do. You can do a network. So there are a million things that happens in your network every day. Also, those millions of things happens, you have zero knowledge. So basically, you have no control at all. You think you control your computer, but chances are you have no idea what's going on in your computer. So another thing, you get a little bit of knowledge about your computer. It's called Wireshark. Wireshark is my favorite program to get something going on, to get a little bit of understanding of what's going on inside my house. Wireshark is a packet analyzer. It will analyze everything goes. It's like the guy handled the mail for our campus. Every piece of mail is handled through this mail guy. So he physically passed through. So this Wireshark can do the same thing. Can check out everything goes in and out of your house. With the right knowledge, you need really, just like Joe was talking about, you need some knowledge to get the job done. You need knowledge about all the package, internet, how the TCP/IP. Basically, you need a lot of knowledge on TCP/IP. That's a different subject, but I just point you to the right direction. Some of you are bored, right? Have a huge amount of time, and are young. If I'm 30s and 20s, yeah. You have a young and fresh mind, curious, then you can just go around, sniff around. Wireshark is called a packet sniffer. It's like a dog sniffing around. Wireshark potentially can eavesdrop, but it's getting harder and harder. In the good old days, eavesdropping is so easy. Now it's difficult because the technology evolves. All right, that's another thing I want to mention. So that's chapter 17. Chapter 17. We talked about multi-user. So this computer really powerful. It's not just like a little thing for play games or a little thing to do watch TV. It's much more. Put it this way, it is the most sophisticated computer system. It's everything we ever developed. It's all on this platform, Unix platform. So let's move on to our next topic. So run levels, you can have 100 user or 1,000 user, doesn't matter. Linux can handle it. You might give a username password to your family member and have them VNC and use your computer that way. So they will have a Windows. In the old days, we just have an X terminal. That X terminal is actually can be a piece of hardware. Just do one thing, VNC. So that's when I was graduate student, we have 10 VNC terminals in our computer lab. That's it, nothing else. So it's just a monitor, VNC to our big workstation in our department. Everybody use, even the professors. Every professor has a X terminal. And that X terminal is just do one thing, VNC to our department workstation. I heard the cell phone. I heard rumors. Have you guys heard the rumors? The new cell phone? It's a pure cloud-based cell phone. I think it's a great idea. The cell phone will be a pure cloud-based cell phone. So the cell phone is only a display, nothing else. There's nothing inside the cell phone. All you need is a display, is a terminal, or X terminal, or a cell phone terminal. So every cell phone, the cell phone manufacturers you do not have to pay $100 or $1,000 for a cell phone. Every cell phone is $10. Okay, $50. That's how much a display costs you, right? A good display, $50. So every cell phone is $50 with a high-speed network connection. So all you need is a high-speed 5G. 5G is supposed to be super fast network connection. So that's your cloud-based cell phone. Nothing needed. All you need is is network connection and a little screen. You do not need to install, all the programs are cloud-based, everything. All data, everything. And then when you lose your cell phone, no worry, because nobody cares. The cell phone is disposable. Or you can put cell phone anywhere. It became like a book, shared cell phone. Nobody need to carry a cell phone. All you need is go someplace, pick up a display, and do your thing, and then drop it. Somebody else will pick it up again. So that's called a cloud-based cell phone. Good idea. I was thinking, yeah, hopefully it will happen. Next topic, chapter 18, is this nice command called vcgen command. This command has a huge amount of functions. So I'm not very familiar. I just know a little bit. For example, you can measure the clock rates. I actually did overclocking during the weekend. I overclocked my Raspberry Pi just for experiment. It works pretty good. It does crashes. So I didn't use my Raspberry Pi for a couple of days. This morning, I want to turn it on. SSH to my Raspberry Pi, it crashed. So if it crashed, that's no good. So I did my overclocking and I changed it back this morning. So I stopped overclocking. And I do notice when I'm overclock, I measure my clock. My clock actually, this is something the CPU manufacturer did. The clock rate is floating. It depends on the temperature. So if your computer is running too hot, the temperature is too high, you can get the temperature using this command. So this is the temperature command. No. There is a command to measure temperature. That's the voltage. You can measure the voltage. So this command can measure voltage. Measure voltage, measure clock, measure temperature. Temperature, yeah, right here.
Dr. Zhang, we can't see it.
Oh, yeah. That's, did I share that? I thought I shared. Yeah, let me share preview. So this command can measure the temperature right here, measure the voltage. That's how you measure voltage, VNC. Measure voltage. So it's nice. If you want to measure voltage, just vcgen command measure voltage. It can also measure clock speed. That's a clock. That's the command. I highlighted the command. What is something else over here? These are just scripting language, script to put the result in a better reading format, to reformat the results. So the result will be very nice like this, not just something very hard to read. Reformat it for people to either read by people. So the voltage is 1.2. You can increase voltage to 1.5, I think, but you run in a risk of avoid warranty. So if you put the voltage too high, one fuse inside that chip will blow, and that will indicate you have done something terrible and avoid warranty. So that's this command is so useful. The author put a single chapter cover that command. So very nice. I need to use more of this command, experiment different features. So every command in Raspberry Pi Unix came with a standard help. So if you're familiar, you will be if you're unfamiliar, kind of a struggle initially. So it takes a while to get used to the help system for Unix. It's a different from a help system. Right now, they are getting similar. They are all web page documents. They are getting together anyway. The next topic will be the Linux console. I talk about the very short chapter. I didn't pay much attention. So the last chapter we're going to cover will be the cross compile. As I said, Raspberry Pi Unix, not Raspberry Pi Unix. It doesn't matter. It's the BSD version or the Linux version. Everything you can find the source code. So every program you run in Raspberry Pi, you can always Google and find the source code. So why do you need the source code? Well, once you have the source code, you can create your own binary. So you can compile the source code. So Raspberry Pi can compile its own operating system. So if you want to recompile the whole operating system, you can do it. The problem is Raspberry Pi is kind of slow, so it may take 2 hours to recompile your operating system. For some small programs, it's doable. For large programs, compiling the source code is a huge headache on Raspberry Pi. Too slow. So that's what cross-compiling came into play. You can have a big supercomputer. The United States have a couple of supercomputers. The world, I think, I haven't been paying attention, but the world quickest, fattest supercomputer is a competition between China and US. So for a couple months, China had the biggest, fattest supercomputer, and then the United States take over, then China take over. So I'm not sure, but the US has a couple supercomputers. So those supercomputers are super fast. So something take hours on your Raspberry Pi take a millisecond, even less than a millisecond on those supercomputers. So how nice, something you have to wait for 3 hours. If you do it on supercomputer, take a millisecond. So that's what cross-compiling comes to play. Cross-compiling means you're using another computer to compile a program on a small computer. So cross-compiling can be done in your desktop. So your desktop is much faster than Raspberry Pi. Your desktop has a big hard drive, has a large memory, and a fast computer. Unfortunately, I do not have. I haven't bought any desktop past 10 years. So all my computer is over 10 years old, or even longer. But anyway, if you have a faster computer, that's a good idea to do cross-compiling. It's a preferred way to develop software. So those software engineers, for example, if you work in Amazon or work in Microsoft, if your source code need 2 hours to compile, well, it doesn't make sense. These software engineers are too expensive, so they don't want the software engineer to drink a tea for 2 hours while their code is being compiled, right? So that's cross-compiling happens. They want them to use a supercomputer to cross-compile their code. So instead of drink tea for 2 hours, they can only drink tea for 2 milliseconds, and then they start working again. So supercomputer cross-compiling, extremely useful information, maybe not relevant to us. Some of us, we will never compile. I did compile source code, including the Raspberry Pi operating system. One thing, why do you want to recompile? Because you modified it. This complete system is under development all the time. So everything is under development. It's an open source environment. Open source means everybody can make your contribution. That's how the open source survive or make progress. It's depend on everybody make small contributions. So with everybody making small contributions, that's how we move forward. So once you make your contribution, if your contribution is good, it became the official distribution. So everything you modified, you will put your name in the comment section. So if you download those source code, you read the source code, you will find the comments. Those comments will have authors. So that's how they get their credits. So for example, some of you are really interested in coding, and you can look at the source code and make your own contribution. Once you make your own contribution, generally they have internet group. So most people. So if you're interested, you join the group. Once you join the group, then you became part of the group. Your contribution will be analyzed by the whole group, and then if they decided it's good enough to become an official distribution, and you became famous. Nobody knows. Nobody cares. Anyway, but that's how the open source. I actually did this when I was a student. I modified one very common image programming for my research group. For my research group, we use this general image processing software, but it's general. Our research group needs something, some module, some extra function, just related to our research group. The data format, the algorithm, the DSPs, all those are developed by our research group, and it's not in the general distribution. So my boss actually didn't ask for it. I just read in the source code. I decided, hey, why not I just put all the development from our group, put it inside that general program. And I did it. It's pretty good. So ever since then, our group began to using that special modified application programs for the whole group, share ideas, the new algorithm we developed, we can put into it. But that is only used by maybe less than 10 people, not you do not get paid anything. Again, open source, anybody makes contributions for free. A lot of those contributors is actually real software engineers work in Apple, for example. A lot of time you see something related to Apple. Only people work inside Apple know those technical details. So, for example, Apple AirPlay. AirPlay can run on Raspberry Pi. Who wrote those code? If you do not have internal knowledge about Apple, it's impossible for you to write any code to port, because Apple do not want people to do it. Apple actually shut off AirPlay for pictures and videos ever since ISO 9. Before ISO 9, you can do AirPlay. After ISO 9, they closed it. But with that, but we still can do it on Raspberry Pi. So obviously, somebody inside Apple helped with the code development process. I was just guessing. So that's all I want to talk for today from the textbook. The next subject will be the Node-RED. Again, Node-RED is something very nice. It's already installed on your Raspberry Pi. So Node-RED, you do not need to reinstall Node-RED, already installed. But there is one module of Node-RED called dashboard. You need to install that. So let me show you how to install Node-RED dashboard. All right, this is a little instruction, very easy. I did it last night. I restart. So start from finish. That's how you install Node-RED dashboard. So start it from here. I will highlight it. Start it from here. End it here. That's how you need to do. You do not need to reboot. Last night I did not reboot. It works, but the reboot is a good idea to get a fresh start of everything, your new installation. So all you need is run this command. If you are using Raspberry Pi now, you can do it now. Have it installed, Node-RED dashboard. The first instruction even don't need it. If your Node-RED is not started, chances are you haven't started Node-RED yet. So if you are using Raspberry Pi now, just type those commands, very simple, and install Node-RED dashboard. So what happens next? After you install Node-RED dashboard, you log in to your Raspberry Pi. So let me do the login. So I will log in. So let me share my login. So I will switch my share. So if you need those instructions, you can take a picture or whatever. Now I will switch over to my terminal. Okay, so I will switch to my terminal. Right now I'm on Raspberry Pi, so I need to start Node-RED. So all I need is after installation. So this is after installation. I type Node-RED start. That's all you need to do. It will start the Node-RED. I did this before the class. Instead of start Node-RED, it's lock up my computer. So I hope it didn't do it next time. Okay, didn't lock up. So it will start the Node-RED. It takes a while.
This is after you install it?
This is how to start it. I already installed. Installation is the instruction I show you.
Right. Mine's saying npm does not support Node.js.
You need to install npm. Yeah, npm.
Install npm?
Yeah, that's one more step, my extra step. But
Okay,
mine is already there. I don't know why. Maybe you need to update and upgrade.
Okay, so just update and upgrade then?
Maybe, but that takes too much time. Just install the just install that one program called nmp or npm. I forgot.
Okay. So
That is the installation tool. Yeah, you need to install this npm. That is the installation tool for Java, some kind of Java code. npm, yes. All right, I assuming everybody installed, and now the Node-RED started. Then what? Then all you need is use it, enjoy. So I already started Node-RED. Let's enjoy it. Usually, when you say enjoy, it means suffer. Let's enjoy it. So that's how we enjoy the Node-RED. We go here. When I go to your Raspberry Pi, that's my Raspberry Pi. So once Node-RED is installed, all you need is a web browser. So you can control your Raspberry Pi from a web browser. How nice is that? That means your cell phone. So with Node-RED installed, you can control your Raspberry Pi from your cell phone, or from your laptop, from your iPad. Even if you are not at home, yeah, I do it outside my home. If you want to do it outside your home, you need extra work. That is, open up this port. There are some details. One way to do it is open up your Node-RED to the outside world for everybody to control it. That's not a good idea. So you need some password protection and things like that. Alternatively, is what I did is use VNC. Not VNC. What's the word? VPN, right? Yeah, alternatively, a better way to do it, use VPN. VPN is you can put a VPN server in your home. Once you have a VPN server in your home, you can log into your house from anywhere in the world. I was in China, I log into my house. I was in Europe, I log into my house. Why do I want to log into my house? When I was at McDonald's, yeah. So when I was in McDonald's, I can log into my house. That's VPN. VPN, we can also do VPN on Raspberry Pi. So if you want to do VPN on Raspberry Pi, that's one of our projects. One of our advanced projects is a VPN using Raspberry Pi as a VPN server. So once you finish that project, you will be done. Enjoy VPN. Before you enjoy VPN, maybe 10 hours of suffering. Generally, last semester, one student accomplished the VPN. Everybody else didn't finish because VPN is not difficult, but it's not easy either. So this is Node-RED. On the left side, you have nodes. You have tons of nodes. Every node is, for example, I have a node here called slider. This is a slider node. I grabbed it from here, slider node. Where is slider node? Yeah, slider node. Yeah, that's a slider. And I can delete this node. I have a new slider. I wired a new slider to my pin number 11. I wired a new slider to my gauge. That's another node. And I initialize my slider, initialize it. That's all the initialization I need to do. After I did this, I deploy. It says successfully deployed. After I successfully deployed my Node-RED dashboard, I can enjoy it. Type one extra UI. So now this is the user interface. Okay, that's my hard work. So that's my slider. That happens on any browser. It doesn't have to be the same any browser. So your cell phone will be a perfect choice. So what this does, it will do a slider. Then the slider will send the PWM to pin number 11. So this is the PWM on pin number 11. Say I put it right here, pin number 11. I can change it to pin number 13. All I need is a right-click and hit done. And I redeploy it. After redeploy, when I'm doing this, the LED connected to pin number 13 will be darker and brighter, darker and brighter. I can also do a switch. It will turn on the LED on and off. It doesn't have to be LED. If you know, the LED means air conditioner, means a garage door opener, means a digital lock. So with this node red, potentially you can control anything around your house. This is a PWM control. Not everything needs PWM control. So a lot of devices around your house just need on-off control. So what you can do, you can turn on the toaster from your cell phone, right? The toaster is sitting in your kitchen, and you turn it on and cause a fire unintentionally because nobody in the house, nobody inside. So that is a node red. What is here? Here is a voice module. I didn't so like a
hello W, hello word,
hello W, hello world. Okay, that's another module. I put it over here. I have a keyboard input to audio out. So all I need is to drag my nodes to here. When I do in my program, a 5-year-old can do programming better than me. A 5-year-old can say, hey, yeah, let's do this. Oh, did you see my Node-RED demo? No?
Gauge,
Yeah,
yes.
Yeah, I think I have a new share. I remember this problem. I have a new share. Okay. Yeah, that's the result of my code. So I do this, the gauge will go up and down. Also, that LED will get brighter and darker when I'm doing this.
And so you have to install the dashboard to get that to work?
Yeah, this is part of the dashboard. The hello, this is not dashboard. This is already there. Hello world.
hello world, hello world class, hello world class, hello world class 2, hello world class 20, hello world class 202, hello world class 2020. Hello. Good more. Good morning, Emerald. Good morning, Mary. Good morning, America.
I type it wrong. I'm mad.
Good morning, Am. Good morning, Am. Good morning, America.
All right, dashboard. Very interesting. Very nice. You instead of control your Raspberry Pi through SSH through VNC, now through a browser, web browser. In order to have that control, all you need is put some node in the development. This is kind of a Node-RED IDE. So the IDE is a web browser also. So you put your development. I actually did, you can also have email, Twitters. So the function is unlimited.
Is there some place we can get some basic training with this? Because I've never seen this before.
Just Google Node-RED tutorials. Yeah, excellent tutorials on Google. Yeah, good question. I actually sent an email. For example, I connected my Raspberry Pi to the sensor on my front door. So every time my front door opens, it will send me an email saying front door opened. And then my sensor malfunctioned. I got 1,000 emails as front door opened, and the Google just so angry they almost threatened to close my account because Google is thinking I am just a bad player. 1,000 email in like 5 minutes because my sensor is kind of I don't know. It has a bad wire, bad connection. The sensor has a bad connection. The sensor is wired by the previous house owner. They did this security company wired the sensor there. But it was 20 years ago. They wired it. So the connection is, I guess, something happened over there. So the connection is right now doing crazy, not solid. So suppose you have a sensor around your house. That's what you can do. You can actually wire all the sensors to Raspberry Pi, and have a node RED to monitor your. So instead of paying those security companies, you'll monitor your house through email. So every time, for example, somebody breaking in, somebody enter, you just send an email or Twitter or. There's many choice network. Okay, so you can do a email. Where's the email? You can store a file, put it in a hard drive. That's another good idea. I didn't find the email. What? No email. Maybe that's why they shut off the email, because the people are sending thousands of emails automatically. Oh, I just noticed the email is out. Email on Twitter, you can send Twitters. Maybe you can Google it.
There's a thing there that says notification.
Oh, yeah. Notification. Yeah, that might be. They might compile it. Yes, maybe hide it somewhere. Yeah. Well, one nice thing about this is the Raspberry Pi has so many GPIOs. So that means you can control, for example, here, this GPIO control your air conditioner. This one control your garage door. This one control your front door lock. This one will be the sensor. This one will be your basement motion sensor. This one will be whatever. You can just do so many. So many GPIOs. All those greens are GPIOs. There's only about 20. What if you need 100? If you need 100, you can buy a module called, you can actually make it yourself, called the GPIO extender. It will create even more GPIOs out of the limited GPIO you have over here. So if you need 1,000 GPIO, it can be done. Just hardwire another extender to this computer. All right, that's all I have for today. And if you guys have any comments before.
I actually do.
Okay, Jeremy, show something.
Well, so getting back to the booting in the beginning. So like you're saying that we can boot our Pi files to the Ethernet and then we won't need our SD card, right?
Yes, that's correct.
So I just need to Google on how to use my Ethernet cable, and
I have instructions on my document. I will put that the instruction. Yeah. Yeah, okay. You can Google it. Yeah, you can find your own instruction. But I found this instruction very good. I will share it with you. That's where
Okay.
Where is it? Let me share it.
Well, because like you said, like the SD card, I mean, will eventually wear out. So I was gonna.
Yeah, right. The SD card is not a good hard drive replacement. Yes.
Well, I saw this one case called Pi Pro, and it has a STD and HDD hard drives slots. So then you can use those instead of a SD card.
Yeah, yeah. STD hard drive.
Or
Okay.
SSD.
Oh, SSD. Yeah, the
Yeah,
SSD
yeah.
hard drive is the perfect choice. It will be a great alternative. You plug into a USB and boot from USB. Yeah. So those are the instructions I have over here, from here to here.
Okay, so just go to that website then.
Yeah, that's my Google. I read it. I found these really good instructions.
Okay.
For example, in a classroom setting, like a college or university or high school, you may have 30 Raspberry Pis, but you don't want 30 SD card plugged in. So all you need is a server, which has all the boot images.
Okay.
And then the 30 Raspberry Pi will all connect to the server through Ethernet.
Right.
And then every Raspberry Pi will be loaded up without SD card using Ethernet.
Right.
Then you will manage 30 images. Everybody has their own image. The 30 images can be different operating system. Doesn't have to be the same operating system. So everybody can run their own operating system from one hard drive. So you need a server. The server, it can be a Raspberry Pi, can also be a desktop. But that server have to be powered on first before everybody else can power on.
Right.
And the downside is the Raspberry Pi have to be wired network. So you have to have a wire Ethernet cable to the Raspberry Pi.
Okay. Yeah, that's what I have.
Yeah. Alternatively, USB is a good choice. You have a USB SSD drive. You plug into your USB port, and then you don't need the Ethernet. You just have your SD card, or not, have your hard drive together with your Raspberry Pi.
Oh, okay.
Hard drive is a good choice because the hard drive, but unfortunately, for Raspberry Pi 3, I will not do it because Raspberry Pi 3, the USB speed is really slow. So that means even though your hard drive is super fast and super good, nice, and USB is so slow, you don't want to do it. I'm still using SD card.
Oh.
But Raspberry Pi 4 may be a good choice because Raspberry Pi USB 3 is faster, right?
Yeah.
So you can attach a hard drive, get a better performance or similar performance, but with not that reliability problem the SD card has. Every time you write it on SD card, you may write it 10,000 times and the SD card just stop working. I have a couple of SD cards stop working on me.
So which one would last longer, a micro SD card or a USB flash drive?
Hard drive might last much longer. Yeah.
Well, no, a USB. Okay, yeah, never mind.
Solid state hard drive.
Well, no, it's just a USB stick flash drive.
Oh, USB stick. I would say the same. Yeah. If you
Same
plug a USB stick, it's still the flash memory. It just has extra USB. Yeah.
Oh, okay.
I would think the read and write cycle will be the same. I may be wrong. Just Google it. But I think they based on the memory are based on same technology. So their life cycle will be similar.
So then, like, if I want to use a hard drive, do I need to like transfer out of the SD card? And
You do not need the SD card anymore.
You're right. So okay.
Your boot image is on your USB hard drive. For the Pi 3, you blow one fuse, you do an initial setup, and then when you turn the power on, they are not looking at SD card, they're looking for USB and Ethernet. For Pi 4, you do the same thing. Instead of a fuse, you can read this article. Instead of fuse, all you need is do a reconfiguration.
Okay.
You reconfigure your Pi 4 to look for SD card and Ethernet and USB. Yeah, that's a good area. But I will not do it because I'm okay with the SD card. I like simple because anything else will be the hard drive. You have to have another box attached to your.
Well, not this one. Here, I'm going to show you. Can I screen share?
Mm-hmm. So you want to show me something? Share?
Yeah.
Okay.
Yeah,
let me stop my share. Okay. All right.
See it?
That's Pi. Yeah, that's nice. How much does it cost? Like,
It's $55 for pre-order.
oh, wow.
And like, so see that right there? That's a power button, and instead, so here's the USB-C power, and instead of the micro HDMI, it's actually 2 HDMI cable, plugins now. And then
Okay.
I think they added an extra USB. Yeah, because then there's the Ethernet. And then you can add 2.5-inch HDD or SSD.
Oh, yeah.
So like it goes like right here. And then it has its own like heating or cooling system. It's kind of weird. And then you can see the power button right there.
Okay.
So you won't need to like keep unplugging it. But this is for the Pi 4 though.
Yeah, now you have a little computer package. Yeah, with hard drive, with everything.
You can add this for $20.
What's that?
It's a cooling fan.
Okay.
Yeah.
Yeah.
Looks kind of cute. But
yeah. Good idea. You can have a little desktop.
case, yeah.
Yeah, you carry your computer. Everybody carry a laptop. You carry a Raspberry Pi.
There you go.
Yeah, everybody you plug in a TV.
And I finally got my RetroPie games on now.
Yeah. What game is that? Yeah, you just download all the games and put it in the game folder.
Yeah. Want to see all my games?
How about speed? It runs smooth.
Yeah, let me show you actually.
I ran it on my Raspberry Pi 3. I found it not very fast, so I didn't like play video games either. So I just installed it and then deleted it.
Wait, can you see it?
Yeah, yes.
Wait, can you see me in RetroPie?
Yeah, RetroPie. I see your RetroPie.
No. Oh.
I didn't see RetroPie. Yeah, you have to reshare. Yeah, you are sharing your big window, but you have to reshare your RetroPie. Yeah, that's something Zoom speed.
Okay, because on my other screen it's showing inside the RetroPie, but right, the VNC is just showing my screen. Huh. Wait, what's going on?
Okay, I was just interested in the speed. You play smooth, a good experience, because last year I saw some students on Raspberry Pi 4, they play pretty complicated games, like a shooting game.
Yeah.
Very smooth, very nice. Yeah.
Well, I guess you want me to share if you're in, like, inside the screen.
Okay, VNC. Yeah, I see that. Yeah. Maybe that's not shareable.
It's not, which is weird. Huh. I mean, I can do this. All right, I'm gonna do this. Stop share.